Hello everyone, a very warm welcome to all of you on the platform of Exampore. I am Sanjay Tomar, your maths mentor, and I welcome you all in this very important session, guys. What we have planned for you based on trigonometry part 2, guys, and especially inside it, we are going to read trigonometric identities. Especially inside it, we are going to read trigonometric identities, guys, as we have done the basics of trigonometry in the previous class. So we will now move forward to the identities. So please do join, guys, and once you join, please do let me know by the help of your comments as well about your joining, about your coming. Okay, so trigonometric identities is the new topic which we have done basics of trigonometry. We have done some questions over it. Now we will begin with what are the trigonometric identities and how the questions based on them comes in the examination. Let's begin. This is what we have all covered. This was the two questions in the homework. I am not discussing them. Hello, Priyanka. I'm not discussing them because they were only value putting. And I told you very clearly in the previous class that these values, I have also made the tables and you have to only put the value. So there was nothing special in it. You should have made it. Yeah, you should have made it. Hello, Shrivani. Very good afternoon. So value putting questions, guys, we are not discussing as of now. Yeah, value putting questions we are not discussing as of now. So let's begin with some theory part. Then we will move ahead. So the theory part is identities. What are the trigonometric identities and what do you mean by these identities? Identities are the equations or the relations which are valid for every value of theta. Identities or relations are valid for every value of theta, like sine square theta plus cos square theta. Sine square theta plus cos square theta is always 1. Sine square theta plus cos square theta is always 1 for every value of theta. Okay. Now, similarly, sec square theta minus tan square theta is always 1 for every value of theta. And last is cosec square theta minus cot square theta is always 1 for every value of theta. Do you know, guys, why does this happen? Why they are always true for any value of theta? Why they are always true for all values of theta? The answer lies in the definition. You know, sine is perpendicular over hypotenuse. So p square by h square. Cos is base over hypotenuse. So b square by h square. When you add it, it will become p square plus b square upon h square. And p square plus b square is always h square 1. Yeah. So the reason is inside the right angle triangle. Yeah. The reason is inside the right angle triangle because p square plus b square is always equal to h square. That is why this happens. Similarly here, sec theta is hypotenuse upon base, so h square over b. Tan theta is perpendicular over base, so p square over b square. Now, in the base, b square is there. In the numerator, h square minus p square is there. In the numerator, h square minus p square is there. which is also equal to b square, hence 1. So that is the reason, guys, these are being called as identities. That is the reason these are being called as identities. And what do you mean by identities? True for every value of theta. Yeah. True for every value of theta. True for all value of theta. True for all values of theta. Is it clear? Is it clear? Like for examples, if I will say you, what is sine square 90 plus cos square 90? I know none of you know the value of 19. I know none of you know the value of 19, but it's an identity, so it is going to be 1. Similarly, when I will ask you, what is sec square 59 minus tan square 59? Neither you know the value of sec 59, nor you know the value of tan 59, but you know this is an identity, so this is going to be 1. Yeah. So, similarly, when I will ask you, what is cot square 49 minus cosec square 49? What is cot square 49 minus cosec square 49? Tell me, guys. Tell me. Write it in the comment box. Write it in the comment box. Write it in the comment box. -1. Yeah, that is why I have given, because the identity is cosec square theta minus cot square theta. Because the identity is cosec square theta minus cot square theta. So this is equal to 1. So inverse, like this is equal to -1. Well done, Priyanka and Srivani. Yeah? Well done. You are very, very, very vigilant. Yeah, you are vigilant. Yeah, you are vigilant. Now, from the last two identities, there are some relations you can form. From the last two identities, some relations you can form, like from sec square theta minus tan square theta. From sec square theta minus tan square theta is equal to 1. From sec square theta minus tan square theta is equal to 1. You can decode it. You can make its more use. From sec square theta minus tan square theta is equal to 1. You can make it more use. One is sec theta minus tan theta. A square minus B square can be written as A minus B, A plus B. A square minus B square can be written as A minus B, A plus B. A square minus B square can be written as A minus B, A plus B. So, now, what is the relation coming out of here? The relation coming out of here is that sec theta plus tan theta, sec theta plus tan theta, and sec theta minus tan theta are inverse of each other. Sec theta plus tan theta and sec theta minus tan theta are inverse of each other. Sec theta plus tan theta and sec theta minus tan theta are inverse of each other. Means if sec theta plus tan theta is given as A, if sec theta plus tan theta is A, then sec theta minus tan theta will become, then sec theta minus tan theta will become 1 by A. Got it? Got it, bacha? Got it? So sec theta and tan theta are inverse of each other. Sec theta plus tan theta and sec theta minus tan theta are inverse of each other. Okay. Now comes Now comes one more. That is the third identity. Cosec square theta minus cot square theta is equal to 1. From here as well. From here as well. We can derive to it. That cosec theta minus cot theta into cosec theta plus cot theta is equal to 1. So, cosec theta minus cot theta is inverse of cosec theta plus cot theta. So again, no need to write it down again. That if cosec theta plus cot theta is known, cosec theta minus cot theta can also be found out. If any one of these is known, the value of another can be write down directly. If any one of these is known, the value of another can be write down directly. Yeah. So if cosec theta plus cot theta is A, then cosec theta minus cot theta is 1 by A. That is very common now that they are inverse of each other. So if value of one is known, value of another can be write down directly. Clear? Clear, guys? So now you are ready for some questions over it? Now you are ready for some questions over it? So let the questions begin. Okay? Let the questions begin. Let the questions begin. So now it's majorly your commitment. And your answer giving skills. 1 upon cos theta. 1 upon cos theta is sec theta. 1 upon cot theta is tan theta. 1 upon cos theta, sec theta. 1 upon cot theta, tan theta. So, this is already sec square theta minus tan square theta, which is the identity is equal to 1. Which is the identity is equal to 1. Very interesting, guys. This topic is very interesting. Let me tell you, it is very interesting. Once you enjoy it, once you start learning it systematically, you will enjoy it a lot, guys. You might have seen the same enjoyment or entertainment or learning in the part 1 as well, where we discuss about how the sec, tan and cot behaves. Well done, Priyanka. Sec theta plus tan theta is given. What is the value of cos theta? Sec theta plus tan theta is given as x upon y. What is the value of cos theta? Wow. Interesting. Sec theta plus tan theta is given as x upon y. What is the value of cos theta? If sec theta plus tan theta is known, sec theta minus tan theta can be written down directly. Sec theta minus tan theta can be written down directly. And what is it? It is the inverse of sec theta plus tan theta, that is y upon x. Yeah, focused. Sec theta plus tan theta was given. We have write down sec theta minus tan theta as inverse of that value. As inverse of that value. For cos, I think finding out sec would be good. For cos, I think finding out sec would be good. So I'm adding both the equations. So tan will get cancel out and sec will get add up. 2 sec theta is equal to x upon y plus y upon x. 2 sec theta is equal to x square plus y square upon x. Okay, which will you say, sir? Sec theta is equal to x square plus y square over 2xy. So cos theta is inverse of it. So cos theta is inverse of it. That is 2xy upon x square plus y square. I will tell you something more as well. But first we have done it completely. Yeah. Okay. Cool. Now, what is the extra point which I want to tell you? What is the extra point, guys, which I want to tell you? If you have ever seen, or like I'm going to show you, I hope all of you have written down this. Now, I hope all of you have written down this. This solution is absolutely clear to you. So there is no confusion over it whatsoever. Bacha, cos theta, whatever would be the cos theta, it's from the triplet only. Whatever would be the cos theta, it would be from the triplet only. Yeah. And there is a very famous triplet. X square minus y square, 2xy, and x square plus y square. Now they can interchange their positions. Yeah, they can interchange their positions. But hypotenuse is always going to be x square plus y square. Okay. Now, question is asking you the value of cos theta. Cos theta is based upon hypotenuse. Hypotenuse is definitely going to be x square plus y square. So x square plus y square should come in the denominator. Here it is coming in the numerator, here it is coming in the numerator, gone. Here it is coming in the numerator, there and there, gone. In these two options, it is coming in the denominator. But the triplet of x square plus y square has 2xy, not xy. The triplet of x square plus y square has 2xy as the other side, not xy. Answer. What was required? Only the knowledge of this triplet was required. What was required? Only the knowledge of this triplet is required. Is it perfect, guys? Come on, tell me. Is it perfect or not? Come on, tell me. Is it perfect or not? Come on. Okay. Great. That was the complete way. This is the smart way or the thinking process way. That was the complete way. This is the like thought process. This is like the critical thinking. This is like the critical thinking which you can apply and you can mark the answer even without solving it. This is, guys, you can apply, you can mark the answer without even solving it. Yeah. Chalo, next. Next. Expecting the answers soon. Expecting the answers soon. Cosec theta minus cot theta given. So cosec theta plus cot theta is going to be inverse of it. Is going to be inverse of it. Is going to be inverse upon. So we need to do it completely, guys. As you know, there are cos theta as well, there is tan theta as well. We need to do it completely. Cos theta is generally less than 1, tan theta is generally greater than 1, like it can be anything. So we need to do it completely, guys. That is very much certain that we need to do it completely. Okay. On adding both. Okay. If you want to be a bit smarter, then you can find out cot theta. Here you can take a decision of finding cot theta directly. Here you can take a decision of finding cot theta directly because that would be used as tan theta. Because inverse of that would be used as tan theta. However, you find out whatever, it does not matter too much. Okay. So I'm subtracting. It will get cancelled out. Minus 2 cot theta is equal to 4 minus 1 by 4. Oh ho. So cot theta will come negative. Okay, cot theta will come negative. Yeah, cot theta will come negative. Let's see, guys. Let's see. So minus 2 cot theta is equal to 15 by 4, or cot theta is equal to 15 by 8 with the negative sign. Cot theta is equal to 15 by 2 with the negative sign. Okay. If cot is negative, tan is also going to be negative. Tan is minus 8 by 15. Tan is minus 8 by 15. I think I have not taught you the quadrant. Na? I have not taught you the quadrant. So today is the time has come up when I will teach you the quadrant as well. Tan negative means either second quadrant or fourth quadrant. Negative आना नहीं चाहिए था वैसे, but let's see why it has come up. And there is nothing mentioned about quadrant as well. Okay. If I add up these, guys, if I add up this, guys, then cosec theta, 2 cosec theta will come out to be 4 plus 1 by 4, which is about 2 cosec theta will come out to be 16 plus 1, 17 by 4, or you can say cosec theta will come out to be 17 by 8. So sin theta is going to be 8 by 17. Now, sine is positive in the second quadrant, not in the fourth quadrant. So, sine is positive, but tan is negative. sine is positive but tan is negative, 100% say that it is the second quadrant. It is the second quadrant. I doubt कि examiner ने इतना सोचा होगा. Let's see. Let's see. Okay, 8 by 17. If sine theta is 8 by 17, if sine theta is 8 by 17, cos theta is 15 by 17. Cos theta is 15 by 17. Triplet, because of the triplet. Triplet of 8, 15, 17. मुझे लगता है ये क्वेश्चन गलत निकलेगा लास्ट में, as far as I can see. Getting my point or not? What I'm trying to say? What I'm trying to say, guys, is here the quadrant is going to be used. Here the quadrant is going to be used. Guys, in the second quadrant, you might not be aware that cos is negative. You might not be aware that in the second quadrant, cos is negative. I can definitely say these options are only by considering positive. I can definitely say that these questions are only by considering them positive. These options are given only by considering them positive. So we can challenge this. We can challenge this. Got it? Got it? Okay. We can challenge this. Because if you take cos positive, tan positive, then answer will match. But guys, look at this logic. Tan was coming negative. Tan negative means either second or fourth. Sine was positive, means second. Means second. In second, cos is also negative. So cos should also be negative. Okay. So we can say not 100% accurate. Not 100% accurate. Technically. So with this, I'm going to teach you the quadrants as well. With this, I'm going to teach you the quadrants as well. With this, I'm going to teach you the quadrants as well. This is being called as first quadrant. This is being called as second quadrant. This is being called as third quadrant. And this is being called as fourth quadrant. In the first quadrant, all are positive. In the first quadrant, all are positive. All means sine, cos, tan, and their inverse as well. In the second quadrant, only sine positive, along with his inverse of cosec. If sine is positive, then inverse, that is cosec, is also positive. In the third quadrant, tan is positive. Tan positive. If tan positive, so its inverse cot is also positive. In the last quadrant, cos is positive. In the last quadrant, cos is positive along with its inverse of sec. Clear? So how do we used to remember it in the schools? How does we used to remember it in the school? All students take coffee. Yeah. All students take coffee. Yeah. This is what we mnemonics what we used to make. Or after school to college. After school to college. There would be few more others, yeah, which you might be knowing. Yeah. Add sugar to coffee. Add sugar to coffee. After school to college, all students take coffee and whatever. Okay. So a lot of mnemonics was there, that in the first quadrant all are positive. In the first quadrant all are positive. Sine, cos, tan and their inverse. In the second quadrant, sine and sec, only cosec are positive, rest all are negative. In the third quadrant, only tan and cot are positive, rest all are negative. In the fourth quadrant, cos and sec are positive, rest all are negative. So in the previous question, you might remember that tan was coming negative, and sine was coming positive. Tan was coming negative and sine was coming positive. So it was the second quadrant. It was the second quadrant. It was the second quadrant. And in the second quadrant, only sine is positive. So cos would also be negative. Now you got it, guys. Why I have technically said that if you go very technically, then your answer would not match over there. And that was required as well, guys. That was the requirement of the time as well. Yeah, that was the requirement of the time as well, guys. Okay, so let's now put it and find out what is the exact answer. Now put it and find out what is the exact answer. Do you remember, guys? Do you remember the values? I think sine was 8 by 15. Oh, sine was 8 by 17. Yeah, it is gone now. Sine is 8 by 17. Tan was minus 8 by 15. Cos theta is 15 by 17. I think it is also negative. Yeah, it is also negative because only sine is positive. So 2 into minus 15 by 17 plus 10, all are negative. Na? So there is no use of solving it because ultimately the answer will come in the negative. Minus 30 by 17 minus 8 by 15 minus 1. You will take the LCM of 17 and 15. 225 plus 50, 275. 275. Where it is? 225 plus 30, 255. 255. For the sake of marking, you can mark the answer as this one in the examination hall, but you will get the bonus. Yeah. For the sake of marking, you can mark the answer in the examination hall, but you will get the bonus. Yeah. Only 255 denominator is only one question. Let's move on. So today we have done one more subtopic as well, which is quadrant. Yeah. Today we have done one more subtopic as well, which is quadrant, and we have read the identities. Now it's all about doing few more 5 to 6 questions and then finishing up today's day. Tan A is 4 by 7. Right angled at B. Tan A is 4 by 7. So for A, this is the perpendicular and this is the error prone zone. For A, this is the perpendicular, this is the base. However, only A is being asked, so that would not be a problem. What is the hypotenuse? Under root 49 plus 16. Under root 49 plus 16 is 65, root 65. What is sine A? Perpendicular over hypotenuse 4 by root 65. And what is cos A? Base 7 by root 65. This is becoming 13 into 28 divided by 65. This is becoming 13 into 25 divided by 65. 13 5 just 65. Answer is 28 by 5. Answer is 28 by 5. Clear? Shrivani and all others, why you are not able to give the answer within the time? Why you were not given the answer on time? Okay. Let's move on to the next question. Now the use of the first identity. Now the use of the first identity which I am going to teach. Now the use of the first identity which I am going to tell you. Yeah. No issues, no issues. What I have done, guys, what I have done, if A sine theta plus B cos theta is C and B sine theta minus A cos theta means change of coefficient and change of sign. Change of coefficient and change of sign. Yeah. Change of coefficients among cos and sine and the change of sign in middle. Then the condition which comes out is A square plus B square, sum of the squares of coefficient is equal to C square plus D square. Sum of the square of coefficient is equal to C square plus D square. I can show you the proof as well if you want. So here the condition is same, that coefficients are interchanged with the change in sign in one place. Coefficients are interchanged 4, 5 with the change in sign at one place. Yeah. If you like write this first and this later, then you will see that the change in sign is also there. So whenever the coefficients are interchanged and there is a change of sign at one place, what happened, bacha? What happened? So sum of squares of coefficient 5 square plus 4 square should be equal to A square plus B square. So A square plus B square is equal to 25 plus 16, 41. What happened, Shrivani? What happened? Coefficients are interchanged and with the change of sign at one place. Clear? The derivation is squaring and adding. Derivation is squaring and adding. Do the derivation, and if you okay, Priyanka, should I derive this condition or what? Or only I should repeat this part where we are applying this condition? Should I derive this condition, or only I will tell you the part where we are applying this condition? Five sin x minus 4 cos x is equal to b. Let's given. Okay. Then keeping sign here, you will say, sir, it's 4 sin x. It's 4 sin x plus 5 cos x is equal to 8. Okay. Look at both of them carefully. Look at both of them carefully. Coefficients are interchanged with the change of sign. Coefficients are interchanged with the change of sign. Coefficients are interchanged with the change of sign. So we will say, sir, square of coefficient 5 square plus 4 square should be equal to square of opposite side values b square plus a square. So a square plus b square is equal to 41. Is it cool now? Is it cool now? Is it cool now? Okay. Okay. Derivation would be squaring and adding both equations. You will get the answer. Yeah. Derivation would be squaring and adding both these equations. You will get the answer. Yeah. If you are interested, I can do, guys. If you are interested, I can do. Squaring both. A square sin square theta. Oh, b square cos square theta. Plus 2ab sin theta cos theta. Big. In the second equation, b square sin square theta plus a square cos square theta minus 2ab sin theta cos theta is equal to d square. Squaring. If you add these two equations, 2ab sin theta cos theta minus 2ab sin theta cos theta will go. So a square plus b square sin square theta plus a square plus b square cos square theta is equal to c square plus d square. If you take a square plus b square common, then sin square theta plus cos square theta, which is equal to 1. What is sin square theta plus cos square theta? Is equal to 1. So, if sin square theta plus cos square theta is equal to 1, then condition comes a square plus b square is equal to c square. Hence proved. Clear now? Guys, hence proved. Perfect. you made me you made me do the derivation as well, okay? Just for you. Just for your better understandings. Okay. Especially mentioned about something. Especially mentioned about something. Let me check whether you can take care of that point or not. Let me check whether you can take care of that point or not. You should, guys, because I've taken it very deeply. This is the question based on yesterday concept and today's concept. Why this is being written? It has some specific use. It has some specific use, that is why it is being written. 10A is 10A is 21 by 20. 10A is 21 by 20. Guys, can we use sine and cos in the ratios? Can we use sine and cos in the ratios? Come on, tell me. Yeah, we can do such thing. We can do such thing. So if you use sine and cos in the ratio, if you use sine and cos in the ratio, very, very critical points what we are doing as of now. Sine A is 21K. Sine A is 21K. But in the third quadrant, sine is negative. In the third quadrant, sine is negative, minus 21K. Cos is minus 20K, because in the second quadrant, cos is also negative. Now, since both of them are negative, so negative is not playing any role. If one of them would be negative, negative would be playing the role. If one of them would be only negative, negative would be playing the role. So, if I would be the examiner, I would have kept 10A as well. So, one negative, one positive. Okay, cos is minus 20K and 5 by 7 sine A is minus 21K. So, it is minus 105K plus 40K upon minus 80K plus 15K, which is minus 65K upon 65K. So even finding out their exact values were also not compulsory, only taking it in the ratio, that sine A is like anything 21K and cos A is 20K. Both of them in the third quadrant, both of them are negative. If I would have made this question, I would have definitely kept at one place 10A as well. So value of 10 you need to put positive and value of sine and cos you need to put negative. 99% of the student would have done the error then. The 99% of the student would have done the error then back then. Is it true or not? If this point I would have taken like whoever keeping it 10A, keeping it 10a over here. So sine negative, cos negative, but 10 positive. Isn't it all of you have done the errors? Okay. So with this, I'm finishing today's day. These are the questions for you in the homework. I might take some of the questions. In the next class of today's homework. You need to reply in the comment box. The logic what we have just taken. This. And this is all we will discuss it later on then. Yeah, this is all will, not too much of homework, only 2 to 3 questions. So those who have not installed the Exampur app as of now, please do install it, guys. Go to the Play Store, install it from there. Then the Exampur app will come. Then you have to register over there. And this page will open. After this page, guys, you will start enjoying on the Exampur app. So take care of yourself, guys. Have a great time. See you in the next session. Do not forget to join me over there as well. I will continue this trigonometry in this manner only for the next 3 to 4 days. Those whosoever want to learn the trigonometry, guys, please recommend these classes to those students as well. We are going to clear our concepts in good detail and with good practice questions as well. Take care of yourself. Have a great time.